The ocean, the most extensive and influential feature of the Earth's surface, covering the majority of the planet and playing a fundamental role in sustaining life. It is a vast, continuous body of salt water that surrounds continents and islands and connects all parts of the globe. The ocean regulates climate, supports diverse ecosystems, influences weather patterns, and provides essential resources for human societies. Although humans have depended on the ocean for thousands of years, much of it remains unexplored, making it one of the least understood yet most critical components of the Earth system. The ocean affects nearly every natural process on Earth. It stores and redistributes heat, drives the global water cycle, and supports countless forms of life ranging from microscopic plankton to the largest animals ever known. Because of its size and complexity, the ocean is often described as the planet's life support system. Understanding its overview, surface characteristics, location, and size is essential for appreciating its importance to both nature and humanity. Overview of the ocean. The ocean can be defined as the interconnected mass of saline water that occupies the depressions of the Earth's crust. Although it is commonly divided into separate oceans for geographical and cultural reasons, it functions as a single global system. Water moves continuously throughout the system due to winds, tides, differences in temperature, and variations in salinity. These movements create waves, currents, and circulation patterns that link distant regions of the world. The origin of the ocean dates back billions of years to the early formation of Earth. As the planet cooled, water vapor in the atmosphere condensed and fell as rain, gradually filling basins in the Earth's crust. Over time, geological processes such as volcanic activity and plate tectonics shaped the ocean floor, forming ridges, trenches, and plains. These processes continue today, constantly modifying the structure of the ocean basins. The ocean is essential to life on Earth. Marine plants, particularly phytoplankton, produce a significant portion of the oxygen in the atmosphere. The ocean also absorbs carbon dioxide, helping to regulate the planet's temperature. In addition, it provides food, minerals, energy, and transportation routes that support human civilization. Without the ocean, Earth would be a vastly different and largely uninhabitable planet. Surface of the ocean. The surface of the ocean is the boundary where water meets the atmosphere, and it is one of the most active regions of the marine environment. This surface is constantly shaped by wind, temperature, and atmospheric pressure, resulting in waves and surface currents. Even when the ocean appears calm, it is still in motion, responding to forces acting upon it. Temperature at the ocean surface varies widely depending on geographic location and season. Tropical regions receive more direct sunlight and therefore have warmer surface waters, while polar regions experience extremely cold conditions and may be covered by ice for much of the year. Ocean currents play an important role in redistributing heat, carrying warm water toward the poles and cold water toward the equator. Salinity is another key characteristic of the ocean surface. It refers to the concentration of dissolved salts in seawater and is influenced by evaporation, rainfall, river input, and ice formation. High evaporation rates increase salinity, while heavy rainfall or freshwater inflow lowers it. Variations in temperature and salinity affect water density and contribute to the movement of ocean currents. The uppermost layer of the ocean receives sunlight and supports photosynthesis, making it the most biologically productive zone. This surface layer is home to a wide variety of marine organisms and supports most of the world's fisheries. The interaction between the ocean surface and the atmosphere also influences weather and climate, including the formation of storms, hurricanes, and monsoon systems. Location of the ocean. The ocean is globally distributed and surrounds all land masses on Earth. It occupies the low-lying areas of the planet's crust and forms a continuous network of water that connects every region of the world. Unlike land, which is divided into distinct continents, the ocean has no true boundaries, allowing water to circulate freely across vast distances. For convenience and study, the ocean is traditionally divided into major regions known as oceans. The Pacific Ocean is the largest and deepest, extending across a vast area between Asia, Australia, and the Americas. The Atlantic Ocean separates the Americas from Europe and Africa and is known for its important role in global trade and transportation. The Indian Ocean lies between Africa, Asia, and Australia and is strongly influenced by seasonal wind patterns. The Southern Ocean surrounds Antarctica and plays a critical role in global circulation by connecting the other major oceans. The Arctic Ocean, located around the North Pole, is the smallest and shallowest and is particularly sensitive to environmental change. Beneath the ocean's surface lie complex geological features. Continental margins mark the transition from land to deep ocean and include shallow shelves and steep slopes. Farther from land, the ocean floor is characterized by vast plains, underwater mountain ranges, and deep trenches. These features influence ocean circulation, marine habitats, and geological activity. Size of the ocean. The size of the ocean is immense, making it the dominant feature of the Earth's surface. It covers approximately 71% of the planet, giving Earth its distinctive blue appearance when viewed from space. This vast surface area allows the ocean to absorb and store enormous amounts of heat, which helps stabilize global temperatures. In terms of volume, the ocean contains the overwhelming majority of Earth's water. This massive quantity plays a central role in the global water cycle, providing the source of evaporation that leads to cloud formation and precipitation. The ocean's capacity to store water and heat makes it a powerful regulator of environmental conditions. The depth of the ocean varies greatly from shallow coastal waters to the deepest trenches. While the average depth is several thousand meters, some regions plunge far deeper, reaching depths that exceed the height of the tallest mountains on land. These extreme depths create unique environments with high pressure, low temperatures, and complete darkness. Compared to land, which occupies less than one-third of the Earth's surface, the ocean clearly dominates the planet. This imbalance highlights the importance of marine environments in shaping Earth's physical and biological systems. Structure and layers of the ocean. The ocean is structured both horizontally and vertically, creating distinct regions with different physical and biological characteristics. Near the coast, shallow waters interact closely with land and receive abundant nutrients, supporting high levels of biological productivity. Farther offshore, the open ocean extends across vast areas with fewer nutrients but still supports life adapted to these conditions. Vertically, the ocean is divided into layers based on light availability. The upper layer receives sunlight and supports photosynthesis, while deeper layers receive little or no light. As depth increases, temperature decreases, and pressure increases, creating challenging conditions for life. Despite these extremes, many organisms have evolved specialized adaptations that allow them to survive in the deep ocean. Role of the ocean in Earth systems. The ocean plays a central role in regulating Earth's climate by transporting heat around the globe. Warm currents carry heat away from the equator, while cold currents move cooler water toward lower latitudes. This process helps moderate temperature differences between regions and influences weather patterns worldwide. The ocean is also a key component of the water cycle. Evaporation from the ocean surface provides moisture for clouds and precipitation, while rivers and groundwater return water to the sea. In addition, the ocean absorbs large amounts of carbon dioxide from the atmosphere, helping to slow the pace of climate change, although this absorption leads to increased acidity in seawater. Human interaction with the ocean. Humans have long relied on the ocean for food, transportation, and economic activity. Fisheries provide protein for billions of people, while shipping routes enable global trade. Coastal regions support tourism, industry, and large human populations. The ocean also holds cultural and scientific significance. It has inspired exploration, art, and mythology, and it continues to be a focus of scientific research. Advances in technology have allowed scientists to explore deeper and learn more about the ocean's role in sustaining life on Earth. Environmental challenges. Despite its vast size, the ocean is increasingly threatened by human activities. Pollution from plastics, chemicals, and oil has contaminated marine environments and harmed wildlife. Climate change has led to rising sea temperatures, melting ice, and changes in ocean circulation. Overfishing has depleted many marine species and disrupted ecosystems. These challenges highlight the need for responsible management and conservation of ocean resources. Protecting the ocean is essential for maintaining ecological balance and ensuring the well-being of future generations. The ocean is a vast, interconnected, and vital component of the Earth system. Its immense size, global distribution, and dynamic surface processes make it central to climate regulation, life support, and human development. From its sunlit surface to its deepest trenches, the ocean remains one of the most fascinating and important realms of the planet. Understanding the ocean is not only a scientific necessity but also a responsibility. As human impacts continue to grow, the protection and sustainable use of the ocean will play a crucial role in shaping the future of life on Earth. The oceans are the largest and most important natural feature of the Earth. They cover about 71% of the planet's surface and contain approximately 97% of all the water on Earth. Because of this vast coverage, oceans play a major role in shaping the planet's climate, geography, and life systems. When viewed from space, the dominance of the oceans gives Earth its distinctive blue appearance, which is why it is often called the blue planet. There are 5 recognized oceans on Earth: the Pacific, Atlantic, Indian, Southern, and Arctic oceans. Among them, the Pacific Ocean is the largest and deepest, covering more area than all the land masses combined. The Atlantic Ocean is the second largest and is known for its importance in global trade and transportation. The Indian Ocean is the warmest and strongly influences weather patterns such as monsoons. The Southern Ocean surrounds Antarctica and connects the major oceans, while the Arctic Ocean is the smallest and shallowest and is covered by ice for much of the year. Oceans are extremely deep, with an average depth of about 3,600 meters. The deepest known point in the ocean is the Mariana Trench in the western Pacific Ocean, which reaches nearly 11,000 meters below sea level. At such depths, the pressure is extremely high, temperatures are very low, and sunlight does not reach, yet many organisms have adapted to survive in these harsh conditions. These deep-sea environments remain among the least explored places on Earth. Ocean water is salty because it contains dissolved minerals, mainly sodium chloride. The average salinity of ocean water is about 35 parts per thousand, meaning that there are 35 grams of salt in every kilogram of seawater. Salinity levels vary depending on evaporation, rainfall, river input, and ice formation. Warm regions with high evaporation tend to have higher salinity, while areas with heavy rainfall or fresh water inflow have lower salinity. The oceans play a vital role in regulating Earth's climate. They absorb large amounts of heat from the sun and redistribute it around the planet through ocean currents. Warm currents carry heat from the equator toward the poles, while cold currents move cooler water toward the tropics. This movement of water helps maintain relatively stable temperatures and influences weather patterns such as storms, hurricanes, and rainfall. Oceans are also a key part of the global water cycle. Most of the water that evaporates into the atmosphere comes from the ocean surface. This water later falls as rain or snow, providing fresh water for rivers, lakes, and groundwater systems. Without the oceans, the continuous movement of water through evaporation and precipitation would not be possible. Marine life in the oceans is incredibly diverse. Oceans are home to millions of species, ranging from microscopic plankton to the largest animal on Earth, the blue whale. Phytoplankton, which are tiny plant-like organisms floating near the ocean surface, produce more than half of the oxygen in the atmosphere. This means that the oceans contribute significantly to the air humans and animals breathe. Oceans provide important resources for humans. They supply food in the form of fish, shellfish, and sea plants, which are a major source of protein for billions of people worldwide. Oceans also provide minerals, oil, natural gas, and renewable energy through tides and waves. In addition, oceans serve as the main routes for international trade, with most goods transported across the seas by ships. Despite their size, oceans are facing serious threats. Pollution from plastics, chemicals, and oil spills has caused widespread damage to marine ecosystems. Climate change has led to rising sea temperatures, melting polar ice, and increasing sea levels. Overfishing has reduced fish populations and disrupted food chains. These problems show that oceans are not limitless and need protection. The oceans are the largest natural features on Earth and possess several key characteristics that make them essential to the planet's physical and biological systems. One of the most important characteristics of oceans is their vast size, as they cover about 71% of the Earth's surface and hold most of the planet's water. This immense size allows oceans to store and distribute heat, helping to regulate global climate and reduce extreme temperature variations between different regions of the world. Another defining characteristic of oceans is their saltwater composition. Ocean water contains dissolved salts and minerals, with sodium chloride being the most common. This salinity gives oceans unique chemical properties that influence marine life and water density. Salinity levels vary from place to place depending on factors such as evaporation, rainfall, river inflow, and ice formation. These variations play an important role in ocean circulation and the movement of currents. Depth is also a major characteristic of oceans. While coastal areas are relatively shallow, the open ocean can reach extreme depths, with deep trenches plunging thousands of meters below the surface. As depth increases, sunlight decreases, temperature drops, and pressure rises. These changing conditions create distinct zones within the ocean, each supporting different types of organisms adapted to their environment. Oceans are constantly in motion, which is another key characteristic. Waves, tides, and currents are produced by wind, gravity, Earth's rotation, and differences in temperature and salinity. Ocean currents move warm and cold water around the globe, influencing weather patterns and marine ecosystems. Tides, caused mainly by the gravitational pull of the moon and the sun, affect coastal regions and marine life cycles. The oceans are rich in biodiversity and support an enormous variety of life forms. From microscopic plankton to large marine mammals, oceans provide habitats for countless species. The upper layers of the ocean receive sunlight and support photosynthesis, making them highly productive and important for food chains. Marine plants and plankton also produce a large portion of the Earth's oxygen, highlighting the ocean's role in sustaining life. In addition, oceans play a crucial role in Earth's natural cycles. They are central to the water cycle through evaporation and precipitation and act as a major sink for carbon dioxide, helping to regulate atmospheric composition. These characteristics make oceans not only vast bodies of water but also dynamic systems that are vital for maintaining environmental balance and supporting life on Earth. The ocean is the body of salt water that covers approximately 70.8% of Earth. The ocean is conventionally divided into large bodies of water, which are also referred to as oceans, in descending order by area: the Pacific Ocean, the Atlantic Ocean, the Indian Ocean, the Antarctic/Southern Ocean, and the Arctic Ocean, and are themselves mostly divided into seas, gulfs, and subsequent bodies of water. The ocean contains 97% of Earth's water and is the primary component of Earth's hydrosphere, acting as a huge reservoir of heat for Earth's energy budget, as well as for its carbon cycle and water cycle, forming the basis for climate and weather patterns worldwide. The ocean is essential to life on Earth, harboring most of Earth's animals and protist life, originating photosynthesis and therefore Earth's atmospheric oxygen, still supplying half of it. Ocean scientists split the ocean into vertical and horizontal zones based on physical and biological conditions. Horizontally, the ocean covers the oceanic crust, which it shapes. Where the ocean meets dry land, it covers relatively shallow continental shelves, which are part of Earth's continental crust. Human activity is mostly coastal with high negative impacts on marine life. Vertically, the pelagic zone is the open ocean's water column from the surface to the ocean floor. The water column is further divided into zones based on depth and the amount of light present. The photic zone starts at the surface and is defined to be the depth at which light intensity is only 1% of the surface value, approximately 200 m in the open ocean. This is the zone where photosynthesis can occur. In this process, plants and microscopic algae, free-floating phytoplankton, use light, water, carbon dioxide, and nutrients to produce organic matter. As a result, the photic zone is the most biodiverse and the source of the food supply which sustains most of the ocean ecosystem. Light can only penetrate a few hundred more meters, the rest of the deeper ocean is cold and dark. These zones are called mesopelagic and aphotic zones. Ocean temperatures depend on the amount of solar radiation reaching the ocean surface. In the tropics, surface temperatures can rise to over 30 degrees Celsius (86 degrees Fahrenheit). Near the poles where sea ice forms, the temperature in equilibrium is about 2 degrees C, 28 degrees Fahrenheit. In all parts of the ocean, deep ocean temperatures range between 2 degrees C, 28 degrees Fahrenheit, and 5 degrees Celsius 41 degrees Fahrenheit. Constant circulation of water in the ocean creates ocean currents. Those currents are caused by forces operating on the water, such as temperature and salinity differences, atmospheric circulation, wind, and the Coriolis effect. Tides create tidal currents, while wind and waves cause surface currents. The Gulf Stream, Kuroshio Current, Agulhas Current and Antarctic Circumpolar Current are all major ocean currents. Such currents transport massive amounts of water, gases, pollutants, and heat to different parts of the world, and from the surface into the deep ocean. All this has impacts on the global climate system. Ocean water contains dissolved gases, including oxygen, carbon dioxide, and nitrogen. An exchange of these gases occurs at the ocean's surface. The solubility of these gases depends on the temperature and salinity of the water. The carbon dioxide concentration in the atmosphere is rising due to CO2 emissions, mainly from fossil fuel combustion. As the oceans absorb CO2 from the atmosphere, a higher concentration leads to ocean acidification, a drop in pH value. The ocean provides many benefits to humans such as ecosystem services, access to seafood and other marine resources, and a means of transport. The ocean is known to be the habitat of over 230,000 species, but may hold considerably more, perhaps over 2 million species. Yet, the ocean faces many environmental threats, such as marine pollution, overfishing, and the effects of climate change. Those effects include ocean warming, ocean acidification and sea level rise. The continental shelf and coastal waters are most affected by human activity. Oceans are essential to life on Earth. They cover most of the planet, regulate climate, support biodiversity, provide resources, and influence weather and water cycles. Although oceans appear vast and powerful, they are vulnerable to human activities. Protecting and conserving oceans is crucial for maintaining the balance of nature and ensuring a healthy planet for future generations. Thank you for watching this video.